Cross-Brain Engineering Arena. My name is Osei, Kofi. You can call me Engineer One. Alright, today we are going to talk about, today we are going to practice about how to construct a hypocycloid. Alright, but before we start, we need to understand the meaning of a hypocycloid. What is a hypocycloid? A hypocycloid is a curve traced by a point of a rolling circle inside another circle. Okay, so let's assume that this is a circular object, and let me see if I can get another circular object. Okay, wait for me, just coming. Right, okay, I think that I have these two circular objects, right? This one and this one. If I place this circular object inside this bigger one and begin to roll this one in the anti-clockwise direction, this smaller object will create a certain circular shape at the end of one revolution, and that curve created by this smaller object inside another circular object is what we call a hypocycloid. Okay, those of you who want to understand the concept of epicycloid can go back to my previous video on an epicycloid. Okay, it is similar to hypocycloid, but the difference is that a hypocycloid is created inside another circle. Okay, whilst when it comes to epicycloid, the curve is created outside another circle. Okay, follow me. We are going to practice about how to construct a hypocycloid. Alright, so let's take a question. Before we start to deal with this question, my advice to you guys over there, especially the students, those who will be sitting for Osei exams, is that you need to also understand the definition. Okay, you need to be able to define it and explain it so that whichever way that the question will be set for you, you are good to go. Alright, let's deal with this question. This is an examinable question, right? A circle of 48 millimeters diameter rolls on the circumference of another circle of 168 millimeters diameter and inside it. Construct the curve traced by the rolling circle at the end of one revolution. Draw the tangent and normal of the curve at the point of 60 millimeters from the center of the directing circle, right? So this is the question, and let's deal with it. I have the data here, and then come close and let's deal with it. So this is the data, okay? In the question, we're given the diameter of the rolling circle, into bracket small d, which is equal to 48 millimeters. We're also given diameter of the directing circle, into brackets d, big D, which is 180 millimeters. Now, what we were not given in the question was the angle of the sector. In that case, you have to determine the angle of the sector. Okay, and this is a formula that can be used to determine the angle of the sector. You divide the smaller d by the bigger d and multiply by 360, and the answer you get is going to be the angle of the sector, right? So in this case, we have the smaller d, which is the diameter of the rolling circle, right, which is 48. And then we have the bigger d over there, which is 180, and it represents the diameter of the directing circle. So you divide the diameter of the rolling circle by the diameter of the directing circle and multiply by 360, and the answer you're going to get is the angle of the sector, right? So basically, these are the information that you need to be able to construct a hypocycloid. In construction of a hypocycloid, you need to draw the angle of the sector. You need to draw the sector first, okay? All right. In drawing the sector, just draw any inclined line on a drawing sheet. Any inclined line at any angle, right? Okay, this is my 60 degrees set square placed on a T-square. So just draw any inclined line. All right. And the diameter of the directing circle has been given, we have to construct the directing circle. Okay, but we are not interested in the whole circle. We are just interested in the angle of the sector, right? So we divide 180 by 2, right? And 180 divided by 2 will give us 90 millimeters. So you take your measurement on your scale ruler or any convenient instrument, and we've been given diameter of 180 millimeters, but we are not supposed to use the diameter to construct it. We have to use what? The radius. So 180 divided by 2, we're going to have 90 millimeters. So you measure your 90 millimeters on your scale rule or maybe any convenient instrument. And this is my 90. Alright. So 90 is here. You can strike any convenient arc. Alright. And then you need to also draw another straight line at an angle of 96 degrees. That is the angle of the sector. Okay. So now we have, this is our point. We can call it point P. Okay, this is our point P. Okay. So what we're gonna do now is to measure our angle with the aid of our protractor. So you place your protractor there. Make sure you place it well. Alright, I think that's correct. And then you measure your angle of, you mark off an angle of 96 degrees on your drawing sheet, right? So 96, this is 90, 95, and 96 exactly will be here. This is 96 degrees. Alright, you have a point there, so we have to draw a straight line to run through the point and then hit the arc. Alright, you can do it with your ruler or any convenient instrument. Now you draw your straight line. Alright, this gives us the angle of the sector, and the angle of the sector is 96 degrees. 96 degrees. That is from here to here, right? Okay, so let me try to indicate it. The arrow. Alright, so this is 96 degrees. So the angle that will be subtended by the rolling circle is 96 degrees, right? Now, we have to divide this sector into 12 number of equal parts. Okay, but before we do that, let's first of all draw our rolling circle, right? Let's draw our rolling circle. Let's understand that the rolling circle is going to roll inside this arc, but not on top of the arc. Okay, since we are dealing with a hypocycloid. So let's draw our rolling circle, and we'll be given the dimension. That is the diameter of the rolling circle, which is 48 millimeters. Now we divide 48 millimeters into 2, and we're going to have 24 millimeters. And we're going to use 24 millimeters to construct our rolling circle, right? So on my scale, let me measure my 24. 24. Yes, I have my 24 here. Right. It's 24. Okay. So let me, first of all, place my compass here and mark off the center of the rolling circle here. Then I can bring one leg of the compass at the point and strike my circle, right? Alright, so this is our rolling circle. This circle is going to roll inside the arc. Okay, so now the next step is to divide the circle into 12 number of equal parts. Alright, to be able to do that, what you have to do, this circle has been divided into 2 number of equal parts, right? So let's try. With the aid of your set squares, you place one of your set squares along the line, this one, right? and then draw a perpendicular line, place another set square on this one, and then you try to draw a straight line, okay, and this line is a perpendicular line, right, to hit the center, right. Now you can extend the line to hit the other part of the circle, right. Alright, so now we have divided our circle into 4 number of equal parts, okay, but we are not interested in 4 number of equal parts, we are interested in 12. So to be able to do that, you have to take your measurement, that is the radius of the rolling circle, right. Take it like this, okay. Then position your compass at one point of the rolling circle here. This way, okay. You strike an arc here, you strike an arc over there. You move to the next point, you strike an arc here, you strike an arc over there, right. You move to this point, you strike an arc here, and you strike an arc over there. Repeat the process until all the 4 points are exhausted. Now this is my last point. I strike an arc over here, and I strike an arc over there. So this divides the circle, that is the rolling circle, into 12 number of equal parts, right. So now let's try to figure out something over here. If this rolling circle begins to roll inside this arc, right, this point is going to land on the directing circle, right. This point is also going to land. Every point on the, what do you call it, the rolling circle will land on what, the directing circle. So it means that if this point will first land on the directing circle, then we can call here 1, point number 1, point number 2, point number 3, point number 4, point number 5, point number 6, point number 7, 8, 9, 10, 11, and finally 12, right. So we have to draw a series of straight lines from the points to pass through the center, right. So you can do it with any of the instrument, any of the set squares. You can use your set square, you can use your ruler, any convenient, instrument, right. So let's start from 1. We draw a straight line to run through the center and hit 7, okay. You move to point number 2. You draw a straight line to run through the center and it's going to hit 8. Point number 3 has already been drawn, okay. 3 and 9, has already been drawn. You move to point number 4. You draw a straight line from point number 4 to run through the center and hit point number 8. You keep on repeating the same process until all the points are exhausted. This is 5. All right, it's done. 6 and 12 are all drawn, right. Okay, now we have divided our rolling circle into 12 number of equal parts. Similarly, we have to divide our sector, or maybe let's say something of that sort. Let's divide our sector or the arc, I'm talking about the bigger arc, into 12 number of equal parts. Okay, so let's do that. To be able to do that, we need to divide this into 12, right? What is the technique? What we're going to do is to divide 96 by 12, right? Divided by 12, because we are dividing into 12 number of equal parts, and this is 96 degrees. So when we divide, we're going to have 8 degrees, and you mark off 8 degrees. So this is 0, 1, 2, this is 5, 6, 7, 8 degrees. You mark it off. 5, 6, 7, 8. You mark it off. 8 plus 8, 16, right? So this is 10, 11, 12, 13, 14, 15, 16. You mark it off, all right? Okay, you continue to mark 8 degrees intervals, right, until you get 12 divisions. So as you can see, we have used the protractor to divide the sector into 12 number of equal parts. We are now going to draw a series of straight lines to run through the points to hit the arc over there. Alright, so just use any of your rulers, right? And then, or any of the instruments, and then you draw a straight line to hit. Continue to repeat the same process until you exhaust all the points. Alright, so as you can see, we have drawn series of lines from point P to run through, the various divisions, and then we have now divided the, sector into 12 number of equal parts. Is that okay? Just as we have done to the circle, to the rolling circle, right? So that is it. In fact, these radial lines are supposed to be construction lines, right? But for the sake of viewers, so that it will appear very clear to you, that is why we try to deepen those lines. But in actual sense, it should be construction lines, faint lines, right? So that is how it moves. So at this time, we are going to draw a series of arcs to pass through the points that we have already indicated on the rolling circle, right? So we can do that by placing one leg of our compass at point P, and then we open our compass to 6, point 6. We strike an arc, right, this way. We open it to 7. 7 will run through 5, right? So run through 5, and we have this arc over there. You continue to repeat the same process. As you can see, this is point 8. You strike an arc to pass through 4, and then you have it over there. And then we have the center of the of the rolling circle, the center of the rolling circle, which is very, very important. So you strike an arc like that, okay, to hit point that is the center of the rolling circle, right? Let me try to deepen a bit, because this point, this arc that we have drawn is very, very important, right? Okay, now we move to point number 9. Okay, we draw our arc, and obviously it will pass through point number 3. Okay, we have it over there. Then you move to point number 10. You do the same, it will pass through point number 2, right? And you have it over there. Then you have point number 11 over here. You draw, and it will pass through point number 1, and you have it over there, right? And finally, point number 12 has already been drawn. Okay. At this point, we are going to draw a series of arcs to define the position of the hypocycloid, right? Where it will show where the hypocycloid will pass, right? And that's exactly what we're going to do. To be able to do that, we have to just take the radius of the rolling circle, right? Take the radius of the rolling circle from any point, right? So we have, this is the radius of it. Okay, before we continue, let me do this. Look, try to label the points, the intersection of the radial lines and the arcs. Try to label it. This center here, call it center CO, that is center 0, right? This point is center 1. This point here is center number 2. This point here is center number 3. And finally here is C12. Right. So that is how it is. So let me try to outline our arc that is running through to the center of the rolling circle. Okay, all right, we have already done that, and so now we are going to position our compass. But before you do that, you take a measurement from your rolling circle, and that is going to be the radius. Okay, you measure the radius over there with the aid of your compass. Then you position your compass at C1, center 1. Strike an arc to cut across arc number what? Number 1. And this is arc number 1. Alright, this is arc number 1. With the same radius, you move to center 2. Then you locate the arc belonging to 2, okay, and you will agree with me that 2 and 10 belong to the same arc. So you cut an arc to cut across the bigger arc 2 and 10, right? So you move to center 3. Center 3, you will agree with me perfectly that this arc, this one running here belongs to points number 9 and 3. So this arc belongs to 3. Then you cut an arc to cut across the bigger arc over there. I call the bigger arc over there 3. Then you repeat the same process. Okay, but you go with me, move along with me. You move to center 4, and then you cut an arc, okay, to cut across the bigger arc 4. Okay, so where is the bigger arc 4? This is the bigger arc 4, 4 and 8, right? This is 8 and it runs through 4. So this is the bigger arc 4, right? Then you move to center 5. You cut an arc to cut across the bigger arc 5. So 5 and 7, right? Okay, belongs to the same arc. Then after center 6, it will not cut across, it will hit the top over there, the apex. Okay, let me call the apex, right? This point. It will hit this point, right? Okay, so then you move to center number 7, right? Center number 7, you strike an arc to cut across the bigger arc 7. Where's the bigger arc 7? This one. So you strike an arc to cut across it, right? 6 is here, so you strike an arc to cut across the bigger arc 7 here, right? Let me mark off 6 so that you don't get confused. This is 6. 6 will not cut across as indicated earlier, so you can mark it, right? Just use a pencil to mark it. Then we have 7. Then you move to point number 8. You strike an arc to cut across the bigger arc 8. Bigger arc 8 is here. Okay, this is it. Move to point number 9. You strike an arc to cut across the bigger arc 9. Where's the bigger arc 9? The bigger arc 9 runs through here. Alright. The bigger arc 9. Where's the bigger arc 9? It runs through 3. So you cut across. This is where you cut across, right? Then you move to point number 10. You strike an arc to cut across the bigger arc what? 10. Okay, you'll agree with me that 10 and 2 belongs to the same bigger arc, right? So this is it. This is where it will cut across. Point number 11, you construct or maybe you draw an arc to cut across the bigger arc what? 11. Right, this is the bigger arc 11. This is the bigger arc 11. And finally 12 will hit the end there, right? So that is how it goes. So now we are done. We have located the points where the hypocycloid will pass. This is the last point, right? So we are now going to draw a smooth curve to run through the intersections of the arcs. So let's try to do it. Let's start from here. This is where we start. And let's try to draw a nice curve, smooth one, to run through here. Alright, so that is our hypocycloid. We are done with it. Level the tangent, right? And if you read the question, we are required to draw a tangent of 60 millimeters from the center of the from the center of the directing circle, right? So that means we have to measure our 60 millimeters with the aid of any scale rule. So 60 millimeters, right? We said from the center, so you position one leg of your compass at point P, you strike an arc, okay, to cut across this hypocycloid. So it will cut across the hypocycloid. So this is the point. Okay, you can mark it off. So we have a point there, and you can call it point Q. This point, you can call it point Q, right? Okay. So what we're gonna do next is to take the radius of the rolling circle, measure the radius of the rolling circle with your compass. Then you position one leg of your compass at point Q. Then you strike an arc to cut across the center arc. This arc, which is emanating from the center of the rolling circle, you cut an arc, okay, or you draw an arc to cut across it. So once you have that point, what you're gonna do next, you have this point, you can call it S, point S, right? So what we're gonna do next from this point is to draw a straight line from point P to pass through that point. So you can do with any of your, instrument. I think this is point S. So place your scale there, draw a straight line to pass through to hit here, right? To hit here, okay, and call it, you can call it any point K. You can call it point K. And so from point K, you draw a straight line from point K to hit or to pass through Q, and that is going to give you the normal, right? So this way, right? You draw a straight line to pass through Q, and this straight line is what we call the normal, right? We have our normal there. What do we have to do next? We need a tangent, and you will agree with me that when we talk about a tangent is any straight line which touches but does not cut through a circle or an arc, right? So we have to find a way to draw a straight line, okay, to pass through point Q, but that line should not cut through the cycloid, okay? And that line too should be perpendicular to the normal. So you can place your set square along the normal, right? And make sure it doesn't cut through. Then you can draw a straight line to hit the point, right? A straight line to hit the point. Okay, you can draw a straight line to hit the point. Yeah, so you have this line here. So you can shift it over there and extend the line. Okay, let's extend it, and you're going to have your tangent. So this is the line. So this is the tangent, right? So we have our tangent over there, and this is our normal. So let's try to indicate it there. So this is what we call normal. So that is our normal. Okay, so when you finish, you have to just try to clean all the unwanted parts away from the drawing. All right, so this is how a hypocycloid is constructed with a tangent, right? This curve is the hypocycloid, right? And this line is the normal, and this line is the tangent, right? And then when you finish, you have to title it, okay? Construction of a hypocycloid. Okay, that's the end of it. viewers, this is where we bring you the end of today's lesson on the construction of a hypocycloid. Don't forget to log on to YouTube and search for Coarse Grain Engineering Arena, and that is where all your technical drawing challenges are addressed. Please like, share and subscribe to the channel. You have a good time. Bye bye.